In this video, you will learn all about the principles of Charles' law. So what is Charles' law? Charles' law, or law of volumes, is an experimental gas law that describes how gases tend to expand when heated. It was proposed by Jacques Charles. He said that when the pressure in a sample of a dry gas is held constant, the Kelvin temperature and the volume will be in direct proportion. This directly proportional relationship can be written as V alpha T, or V divided by T equals K, where V is the volume of gas, T is the temperature of the gas in Kelvin, and K is constant. Or simply, first volume times the second temperature equals the second volume, or the first temperature. Or you can transform this into a fractional form. In this video, we will use the second formula. Take note that the volume and temperature with the same subnumber should only be paired, not with a different one. The idea of this law is, as absolute temperature increases, the volume of the gas also increases in proportion. A 600 ml sample of nitrogen is heated from 27 degrees Celsius to 77 degrees Celsius at constant pressure. Find the new volume. The first thing that we're going to do is to list the formula that we're going to use. So the first volume divided by the first temperature equals the second volume divided by the second temperature. Then list all the given values according to the situation. So the first volume is the 600 ml and its temperature is 27 degrees Celsius, and we are finding the second volume which has 77 degrees Celsius temperature. Now, the temperature should have in Kelvin, so we should convert it by adding 273. By doing this, we're able to solve the formula. We will get 600 ml divided by 350 Kelvin equals the second volume divided by 359 Kelvin. 600 ml divided by 350 Kelvin is 1.71 ml per Kelvin. After this, we will do some cross multiplication. Now the answer is 613.89 ml, and that is our second volume. That is the approximate answer. Now the exact answer is 615.43, but both will do. what volume change occurs to a 400 ml gas sample as the temperature increases from 22 degrees Celsius to 30 degrees Celsius? The first thing we're gonna do is to list the formula and then list the given values. So our first volume is 400 ml and its temperature is 22 degrees Celsius, while the second temperature is 30 degrees Celsius, and we are finding that another volume, so we should convert it into Kelvin by adding 273, and we would get 295 Kelvin and 303 Kelvin. Then we are able to do the formula. 400 ml divided by 295 Kelvin equals second volume divided by 303 Kelvin. Now 400 ml divided by 295 Kelvin equals 1.36 ml per Kelvin, and by doing some cross multiplication, our second volume is 412.08 ml, and that is the approximate answer or the estimated answer. And don't forget the unit. Now the exact answer is 410.85 ml without having any estimation. Five liters of gas is collected at 100 Kelvin and then allowed to expand to 20 liters. What must be the new temperature in order to maintain the same pressure? So first we should list the formula and the given values as well according to the situation. And our first volume is 5 liters and its temperature is 100 Kelvin. And its second volume is 20 liters and its temperature is missing. Take note that our temperature is already in Kelvin, so we don't really need to convert it. Now 5 liters divided by 100 Kelvin equals 20 liters divided by the second temperature. Now 5 divided by 100 is 0.05 liter per Kelvin equals 20 liters divided by the second temperature. Now doing the cross multiplication and dividing it into 0.05 liter per Kelvin, so we should cancel. Then expanding this, we would get 400 Kelvin. And that is our second temperature. And there you go. I hope this was helpful and I hope you learned something and I hope you liked or reacted to this video now. Peace out.